Good afternoon, everyone. So we're going to simplify two decently weird looking expressions using our exponent laws, okay? So for the first one, we have something on top raised to the power of 3 and something in the bottom raised to the power of 4. So let's address those individually. So the cube is on everything inside of these brackets, which means it hits every part of it. So first off, we'll have -2 cubed, which means -8. Then we have 8 cubed, and we have a power to another power. We multiply exponents, and so that's 8 to the 3 times 3, meaning 8 to the 9. And then same thing with the b to the 2 times 3, power to a greater power, which means b to the 6. And that is all over, again, everything inside the brackets is affected by the power of 4 over here. So we have -3 to the power of 4, that is positive 81. Make it nicer 8 here. Positive 81. Now we have a to the 5 times 4 because we have power to a power, right? So that's a to the 20. And finally, b to the 4, because that's b to the 1 times 4, which is b to the 4. And now we can simplify this a bit. -8 over 81. We can't simplify that, so let's make it as -8 over 81. And now we can use our exponent laws on the a's. So a to the 9 divided by a to the 20. When we have the same base and we divide, we subtract exponents. So that's a to the -11, 9 minus 20, a to the -11, right? And b to the 6 minus 4 means b to the 2, b to the positive 2, like so. And now, oftentimes we don't love ending off with negative exponents, and so I would personally write this as -8b squared, and the a to the -11 would flip, right? A negative exponent just flips it to the bottom, and so we would have 81 a to the positive 11 in our denominator. And that's our simplified expression, okay? Now, for our second example, a bit trickier looking. I like to work when we're dealing with exponents inside out, okay? So I'll just make a note that the square here is only affecting the 7 inside the bracket, the 5 is hanging out outside the brackets, so that's left alone for now. So let's work inside out. We will have 5, a cubed squared means a to the 6, right? Multiplying exponents. And now we have b to the -2 times 2, so b to the -4, okay? All over. Now, the -3 is going to affect everything here. There are different ways to handle this. I think what I would do is, I think I would honestly use the negative to flip it over into the top of our quotient here. So I would make the -3 move all of this up top to the numerator, and now just have it to the power of +3. So I would have all this times 2ab cubed to the power of 3. And then I would just have it like so, and then raise everything to the power of -2. Okay? Now, you might notice that we can put the b to the -4 down below in the denominator, because the negative exponent just flips. So I would write this as 5a to the 6. Now we can expand this stuff in brackets. So 2ab cubed is all being affected by the power of 3 here. So 2 to the power of 3 is 8, so times 8. A cubed is a cubed, and b cubed, we multiply the exponents, and we get b to the 9. And now that b to the -4 flips down below in our denominator as b to the +4. And now this is still all affected by the exponent of -2 all the way outside. And so we can keep going. Now, again, I'm always working inside out. We can simplify the b base inside the brackets. We have a b to the 9 divided by b to the 4. When we divide by the same base, we subtract exponents. So we get 5a to the 6 times 8b to the 5, all raised to the power of -2. Right, now we can multiply our coefficients here. So that's 5 times 8 is 40. So that is 40, a to the 6, b to the -5, all raised to the power of -2, right? And now that negative in the exponent flips the entire thing. Sorry, that's a b to the positive 5. Not sure what I was thinking there. B to the positive 5, of course. So now again, everything inside the bracket is affected by the power of -2. So before squaring it, the negative means we're going to flip the entire thing that is inside the brackets. So I'll even bring that over here. We can write this as 1 over all of this, right? Because it's all being affected by the negative exponent. So we get 1 over 40 a to the 6 b to the 5, now raised to the power of positive 2, which means squaring everything. And now we square the top and square the bottom. So we're going to end up with 1 squared is obviously 1 over 40 squared. That's 1600. A to the 6 squared. We multiply exponents. So that's a to the 12. And b to the 5 squared is b to the 5 times 2. B to the 10. And now there's nothing left for us to do. And so this is our simplified version of our expression. And we're done. So I hope this helps. Exponent laws can definitely get messy when there's a lot going on at once. But again, my advice is to work inside out. Hope this helps, and thanks for watching.